the open source foundation for decentralized technology systems, right? Okay, so the idea for bringing this community together started as probably, hey, there are so many DLTs out there. Is there some way we can bring everything under one umbrella? And the core funder of decentralized technology is open source, of LFDT is open source governance and sharing of ideas. When I started contributing to LFDT, it was known as Hyperledger. And I mostly started with Hyperledger Fabric, which was another distributed ledger technology. But today we're sort of growing to expand to even things like decentralized identity. So the LFDT is a part of the Linux Foundation. By embracing open source principles established by the Linux Foundation, LFDT serves as the neutral home for the open development of technologies that empower organizations to innovate with secure and resilient code. Today, we have lots of projects and contributions. We've been in the space for 9 years of community building. I personally used to lead the LFDT India chapter, and we've seen a lot of growth over the 2 years that I was over there. We have about 19 projects, 1.2 million contributions, and a total of 394,000 commits. This slide is just one picture of the LFDT members that we have, and we also have associated members, and this is a community that just keeps on growing. So for this Seattle reboot, the theme is exploring blockchain and identity. How it came about is, in my past life, I used to be a blockchain developer at Walmart. I used to host a ton of LFDT events over there, and then decided, hey, I'm going to be a product manager now, and ended up in Seattle, incidentally in the automated reasoning and identity org, where I'm working on a product called Amazon Verified Permissions, where we deal with identity a lot. So having attended a lot of LFDT meetups and member summits and maintainer days, I realized that there's a very strong possibility of intersecting blockchain as a technology and the identity space. So with that in mind, we lined up a really, really fun lineup of speakers. First, we have a fireside chat with Steve and Jessica. Then we have a talk by a senior applied scientist from my team, which is Emina Torlak. And then we also have Drummond Reed, who is the co-organizer of the First Person Project and the co-chair of the Technical Steering Committee at Trust Over IP. So we're super excited. For those of you watching at home, give a huge round of applause for our speakers. So I'm just going to excuse myself from this panel discussion. The slides aren't updated, but I have to just deal with some logistics. So I'm very happy to extend a very warm welcome to Jessica and Steve. It's so nice to have you folks at the Amazon office. And I'm now going to hand it over to Jessica, who is the Hiero Technical Community Architect at LF, to introduce Steve and take over the podium.
Thank you, Deepika. And thank you so much for everybody that is listening to us. So, as Deepika was mentioning, we're hoping to reboot this group. And I know that back in 2020, we used to have very cool attendance. So we're trying to build exciting topics and anything that the community wants to hear about. So this is our first time after a very long time that we are rebooting the group. And yes, as Deepika mentioned, LF Decentralized Trust helps communities shape the future of digital economy. So our team, and specifically my team, the community architecture team, helps projects adopt best practices for open source in collaboration in their day-to-day activities. So we work very closely with them. We work with a lot of companies that are focused on ledger, they're focused on blockchain, they're focused on identity, and so much more. And so far, I'm here seated with Steve Albonico, and he's a member of Accenture. He works at Accenture, and he has a lot of experience with LFDT. So in our past chat, Steve, we were talking about your experience with blockchain in your day-to-day work. So tell me more about it.
Yeah, absolutely. Thanks for having me here. And I'm Steve Albonico, and I'm so happy to be a part of this new start for the LFDT because I think I've been kind of a consumer of a lot of this group's work over time. So back when it was Hyperledger, I've worked with quite a bit of the different pieces that in the projects that have been created here. And I think my start in my journey through ledger technology and identity and blockchain and all that, I think is something that really is what makes me so excited about the work we do here and being a part of this and hopefully building a community here in the Seattle area to kind of get us more going and collaborative about the different awesome things that we're working to come under this new space. So just a little bit about myself, I started, 15 years ago, actually, believe it or not, in law enforcement. Well, I wasn't a cop, but I was a technical sysadmin back then. And so back then we didn't have a lot of knowledge about distributed ledgers, of course. I mean, phones didn't even have cameras at that point. But over time, we came into contact with Bitcoin. And as we started to slowly understand how Bitcoin worked, I found myself so amazed by the idea of distributed ledger behind Bitcoin, right? So the technology underneath that was so interesting to me. So, as time went on, one of the major things that we did where I worked in California government was federating ID. And if anyone here has worked through the arduous process of federating ID, it can be a long process to try and get these things working. And as it's grown over time, identity has become such a core piece of our ability to transact with each other and do work with each other. And ledgers themselves have become a core piece of how we transact and interact. And the technology has moved so quickly, especially in the decentralized arena, that as I kind of transitioned out of that piece, the next place I wanted to go was somewhere that kind of focused on those technologies. And so the first place I looked to was, of course, the Linux Foundation and their work back then in the Hyperledger piece. Yeah, of course. It was an amazing community with so many open source abilities and tools and projects and learning opportunities. And like a lot of people, I actually started with Fabric, building a little demo with the cars, of course, that they used to have. And we utilized that for, at that point, kind of a little pilot that was kind of for evidence management and document management, because how chains of custody work is actually really perfect for being able for a shared ledger. And part of that, of course, is building that identity layer to bridge the gap of who is actually signing these transactions, right?
Correct.
And so that was a large challenge and still is a challenge for a lot of what we do in the distributed and decentralized network space. And so as I kept moving on through the career, I worked with some aerospace companies and some entertainment companies and some other pieces. And through my work here now at Accenture, I found that technologies and that set of challenges are still something that we are working through today. And the evolutions of that, tying identity to distributed and decentralized ledgers and other types of transactional projects is a wonderful set of challenges, and it sets a lot of different abilities together. Chronology, ledger technology, identity technologies, and so that intersection is kind of what we are focusing on here a little bit with LFDT. And I think there's just so many different cool technologies that we can bring together.
Yeah, absolutely, and we continue to grow. As we were saying earlier, LFDT has been around for maybe about a little bit more over than 10 years. So now with the new projects that we are acquiring and new adventures, I mean, it's definitely going to be growing, and you guys are going to be hearing more about it. And I'm very excited for future talks that we can resolve any questions and also help you bring up these communications a little bit more. So thank you for that, Steve. And just in your experience with LFDT and the work that you have done in the community, where do you want to see this community in the future? And at the same time, for any new member or any new maintainer that hasn't had the experience of working with the LFDT, what would you tell them?
Well, I would say, first of all, reach out to people that you've seen contribute, ask questions, learn. Don't be afraid to work out loud. Don't be afraid to reach out and put out your bad code so that others can take a look at that, right? And don't be afraid of having a little bit of bad code, right? Obviously,
Yeah, absolutely.
Please don't try to push it, but please make it and create it and work on it and do these things out loud so that this community can have these ideas and bring them together. And that's some of the things I'm most excited about this collaboration, is to see people bring their different technologies together, bring decentralized identity together. How can we combine things like verifiable credentials and other identity technologies with ledgers to unlock new ways of transacting, of value, of doing all kinds of use cases, right? That are trusted, right? But still distributed, privacy preserving, and open source.
Exactly. Thank you so much for that. And yes, as Steve says, I mean, I know that sometimes it can be a little bit overwhelming to join a community, and for people that are new to open source, it might be a little bit new to just jump in and start collaborating, right? But as Steve says, just jump in. There's a lot of people willing to help, a lot of information on how to reach a particular community. We have email addresses, we have Discord, we have a lot of public meetings that happen for different communities. So definitely feel free to reach out and join any of these open collaboration calls. Is just a very good first step to get you started. So thank you so much for that, Steve. And I'm gonna pass it now to Emina.
Maybe do the intros. Yeah. Yeah, I can just do it. Cool. I can come over here. Okay. Thanks for that super insightful conversation, Steve and Jessica. So I think they covered the points, but something I also wanted to add was that I started off as a random contributor. I was just trying to figure out how Fabric works, and it is pretty convoluted. And I figured out that in the way you set up the testnet, there was some issue with the documentation. And that was my first issue contribution. And that was 4 years ago, and I'm here today. So I think anyone can really get started with LFDT, contributing to Hyperledger, contributing to the community. So thanks for bringing that to the front, Jessica and Steve. So next up, like Jessica briefly introduced, we have Emina Torlak presenting expressive, fast, safe, and analyzable authorization with Cedar policy language. This is a topic that I am personally super excited about because as an ARI, Automated Reasoning Identity intern, this Cedar is the exact thing that I'm building the product for. So I'm really excited to see how I learn from you. So a quick intro about Emina is that she is our senior principal applied scientist at AWS Automated Reasoning and Identity. She is a computer scientist and software engineer who is also the 2016 winner of the Junior Dal Nygaard Prize for her work on developing tools and methodologies to help build better software easily. She was also the 2021 winner of the ACM SIG Plan Robin Miller Young Researcher Award. She's previously taught at the University of Washington and is super cool. I'll hand over the mic to her.
Thank you very much for that introduction, yeah, thank you all for coming. It's a pleasure to come and talk about how you can secure your applications using Cedar and get expressive, fast, safe, and analyzable authorization. So, we heard some talk about identity, which is, we determines who you are. But once we determine who you are, then we also want to determine what you can do within a given system. And this is the authorization problem that we're interested in solving. Pretty much every web app, every single mobile app that you're using has to solve this problem, right? Banking, online banking, who's allowed to see your account? Well, you and your banker. Who's allowed to see your medical records? Who's allowed to see your Netflix subscription? So all of these things that you're using have to solve this authorization problem. Well, authorization is a really old problem. And in theory, it's a solved problem, right? There are lots of authorization models that you can choose from to secure application. The three most common ones are role-based access control. So you're securing access to your application based on the role that your principal or user has within an organization. Like, are you a manager or a VP? That determines your access. The second one is attribute-based access control, which determines access based on the attributes of the principal and the resource. So for example, every operator can repair machines within their own building, right? So the attributes of the operator and the resource match. And then finally, relation-based access control, which gives access based on relations. And the classic example here would be Google Docs, right? I'm allowed to view documents if I'm in the reader set or the writer set for that document. Okay, so this all seems pretty straightforward, but it turns out that actually implementing one of these access control models within your application is very difficult. To see why, consider this toy application that I'm going to call Tiny To Do. And what Tiny To Do does is it lets users and teams, and here we have some users organized in some nested teams, share and manage and create to-do lists. Okay, and these lists have some attributes here. So, it has a name, it has an owner, it has an editor team, reader team, and so on. Now, when you build a mobile or a web app like this, when the user interacts with the application, that causes some method to be called in the backend. So if you have a to-do list and a user clicks on the button that says, show me the tasks in this list, what eventually happens on some server somewhere, a function like this is going to get called. Okay, so this function first attempts to determine whether the principal who's requesting to perform this get list action on this particular list, let's say 1, 2, 3, is actually allowed to do that. If they are not, you bail. And if they are, you return the contents of the list. What's wrong with this code? Well, first of all, you're embedding your authorization logic within your application. And with these horrible negations, you're actually checking the negation of the thing that you want to establish. And the rules that you want to establish is you're allowed to call this get list of a particular list if you're an administrator, okay? So admins have all powers to do anything they want. If you're the owner of the list, or if you're the editor or a reader of the list. But it's super hard to see that this is what that code is doing, right? This is hard to get right. Security issues often come from these nested statements with these negations. This is really hard to audit. If you want to convince a third party that you satisfy certain access invariants, you have to give them access to the application code, right? And they can't check this mechanically because it is not possible to automatically analyze general purpose code. And finally, this is very hard to maintain. If your access control rules change, you actually have to change and deploy your application. So this is where a better way to do this is known as policies as code. And this is where authorization languages like Cedar come in. The basic idea is to separate your application logic from your authorization logic. So what you're going to do here, we're going to take out all of those rules that we had from the Python code, and we're going to replace them with this isAuthorize call, which is calling an external authorization engine that is going to evaluate a bunch of policies that encode only your authorization logic in a dedicated authorization DSL and return true or false, and then all of the methods within your application, right? Not just getting the list, but editing the list and so on. All they do is they have that one method call, and they're all going to have consistent authorization policies that are stored in your database. And these particular policies are written in Cedar. Even if you've never seen Cedar before, it is very easy to tell that they implement the 3 rules that I've told you before. I was attempting to implement in Python. So anybody can perform any action they want on the resources they own. Admins can do whatever they want, and you can perform the get list action if you are in the readers or the editors team of that resource. Okay, so much easier to read, much easier to modify, much easier to maintain independently of your application. Okay, so that's your first very quick look at Cedar. Cedar is open source. Anything I talk about today, you can find at our GitHub repository. It is used extensively within Amazon. 30+ services and teams use it to secure their applications. We have contributors from many other companies. Some of them are listed there. And it covers a very wide range of use cases, from super classic ones like securing human access to web app to advanced applications that are doing workflow, that are creating workflow policies for AI agents that are controlling, that are interacting with MCP tools. Okay, so in this title here, I said that Cedar is a new kind of authorization language. So what does that mean? What makes it new and unique? Because there are other languages out there that are also designed for authorization. So why did we build another one? And what makes Cedar perhaps interesting and worth looking into if you need to add authorization to your application? There are two unique features of Cedar. The first one is that the language is carefully designed to balance 5 important concerns that we have for DSL in order to achieve uniquely, so no other language has this part, analyzability. So what does analyzability mean? It means that when you give me a set of Cedar policies, we have tools which can look at the text of your policy and automatically prove that your policies satisfy access in areas that you care about. And if they don't, we will show you a test case, an actual input in which your policies will violate that access invariant that you care about. So this is super important for auditing. This is constructing mathematical proofs showing that your policies are doing what they're supposed to be doing. Now, to achieve analyzability, we do have to give up on something, no free lunch ever. And what we do give up on a little bit is expressiveness. So there are other authorization languages that are much more expressive than Cedar. Cedar is designed to be just expressive enough to cover the 3 main authorization models. So role-based, attribute-based, and relation-based access control. It is designed to be ergonomic, so people who are not developers can read and write it. It is performance. It runs in microseconds. And you can run it all the time to implement a zero trust architecture in which you trust nothing and all the requests are always authorized. And it is type safe, and we provide an advanced type checker, we're going to talk about it a little bit later, that makes sure that your policies at authoring time are doing the right thing in terms of respecting type constraints of your application. The second unique feature of Cedar is that it's built from the ground up using automated reasoning, specifically formal verification and differential random testing to ensure that our implementation of every component of Cedar meets a high correctness and security bar. And we're going to talk about that a little bit later as well. All right. So we're going to start with the language design, talk about a little bit about ergonomics and expressiveness, and how we design Cedar to support these common authorization models. So Cedar policies have super simple syntax by design. All the policies are extremely uniform. The first thing that you see is called the policy effect, and it can be one of 2 things: permit access, so it's giving you more access, or forbid access, it's taking away access. The second part between parentheses is called the policy scope, and the policy scope is putting optionally constraints on these 3 policy variables. Okay, so these are coming from the request. The principal who's requesting to perform some action on the resource, you can insist that this policy, for example, is talking about just this get list action. Okay, and then the final part, you can have as many of these as you want. Again, optional, 0 or more, are conditions that can further constrain access, refine your access constraints using expressions in this language that looks a little bit like Google Common Expression Language, if you're familiar with that. Now, these 3 variables, action, principle, and resource in Cedar, are called entities. You can think of them as references, named objects in a persistent data store. And this is an authorization-specific view of application data that's relevant to your application. So for example, principals are entities, and you can organize all entities, not just principals, into hierarchies. These hierarchies are directed acyclic graphs that reflect things that are meaningful in your domain. Okay, so humans, you can put them into teams, organizations, whatever, resources. I don't know if they're photos, you can put them into albums and all sorts of other things. Okay, so hierarchies are really important there. And entities can have attributes, which are records. So maps with a fixed number of fields, and each of the fields has a value. These can be primitives. They can be other entities, which is really important. So there is a way for entities to reference each other. They can be sets and many other kinds of values that are useful in this authorization domain. Now, given the entities and the policies, the request when it comes in essentially provides a binding for these policy variables so that you can evaluate the policies with respect to this binding, okay? So here's an example request. We're asking whether Kesha is allowed to perform the get list action on list 1, 2, 3 in this context. So this is a fourth variable in Cedar that you can use to pass in non-persistent, so transient data. So entities, persistent data, transient data like current time, source IP address, that sort of thing, you would pass that in the context, okay? So given all of this, the Cedar authorization algorithm is designed to allow access by evaluating all of the policies that you have conceptually in your system. And it will say that access is allowed for a request if it satisfies at least one permit policy and 0 forbid policies. So as an example, the request that you see on the slide is allowed. And the reason is that this policy that we have, the only policy in our system, evaluates to true. Why does it evaluate to true? Well, Kesha is a member of the temp team. List 1, 2, 3 has the temp team as its readers. And the policy says, if you're a member of the readers of the resource, you get access, okay? So permit policy, just a filter, Boolean value expression, evaluates to true, you get access. Now, if we change this very slightly, we replace Kesha with Emma here, access is denied because we have only one policy in the system, and it doesn't give access because Emma is neither an editor nor a reader for this resource, right? And the semantics is default deny, which is the secure or safe posture, right? If there's no explicit permit, too bad, you don't get access. And the final example, and to give her access, we have to have another policy. So here we've given her access because she's an admin. And as a final example, we can consider this forbid policy and a request, which is saying whether Andrew can perform the create list action on tiny to do. The answer this time is going to be an explicit deny. So here's how that works. This permit policy gives him access because he's an admin. But the forbid policy takes away access because he's a member of the temp team, and forbid trumps permit. And that is one of the key points of Cedar design, which we have proven holds for our authorization algorithm. So default deny, forbid trumps permit. All right, so we're going to briefly see how you can use these constructs to implement role, attribute, and relation-based access control. So to implement role-based access control, we simply use the hierarchy to encode the roles, okay? And we just put the role-based access control constraints. Usually, you don't have to, you can put them in the condition, but because it's shorter and nicer to look at, we just put them in the scope. So what these constraints are saying is that these principals are getting access based on their membership in this hierarchy. The most important operator in Cedar is this in operator, which is testing transitive membership in this hierarchy graph. So in this case, Aaron is a member of the intern team, and he is also a member of the temp team transitively. So this in operator is magical. It's actually testing this graph reachability here. To implement attribute-based access control, well, we just use conditions, and we use these attributes here in this expression language, which I mentioned looks like a little bit like Google Cell. An important thing to note about this expression language is that it is pure. There are no side effects. You can't affect the external world. You can't write the files. You can't do anything like that, which means that you can run Cedar safely out of a sandbox. It's loop-free, meaning that policy evaluation is guaranteed to terminate. Again, something that we prove. And the operators are chosen carefully so that a typical policy evaluates in linear time with respect to policy size and input size. And of course, they're also chosen carefully so that we can reason about them fully automatically to prove properties of your system. Finally, by combining hierarchy and attributes, you get relationship-based access control. And this is where the magic of allowing you to put another entity as the type of an attribute comes in. To declare a relation, you simply declare an attribute which has an entity as a type, and that type represents a group. And then you can use the in operator to check membership of a principal in a set or a group that's related to a resource. Okay, so that's the language design. We're now going to talk a little bit about the safety and analyzability aspects that are unique to Cedar. So for type safety, we provide a powerful policy validation algorithm that takes as input your policy and what we call a schema. The schema, you can think of it as a database schema, but for your application's data model. It describes what kinds of entities are present in your application, what attributes those entities have, and what the types of those attributes are, and how the entities can be arranged in a hierarchy. So this schema is saying that users can be members of teams, teams can be nested in each other, but obviously teams cannot be nested in users. That doesn't make any sense, okay? So you get all of that from the schema. The final thing that you do in your schema, you list all the actions that you're going to be protecting using Cedar. And for each action, you give us the list of principal types and the list of resource types to which that action applies. Now, given this information, the type checker can tell that my example policy satisfies the schema. Okay, so it can see that it's applying to the get list action. So we know that the resource is a list where the editors and readers are teams. It makes sense to check if principal is in a team. And we can also check a lot of other properties. From all of this, we conclude that if validation succeeds, so if our type checker accepts your policy, we can prove that the evaluation of that policy will never throw a runtime type error when applied to a request and entities that conform to the schema. Okay, so it's a very strong correctness property. Now, type checking is good. I think we can all agree that strongly typed languages are nice. But what it can do is it can't tell you anything about the actual semantics or behavior of your policies. And this is where analysis comes in. A classic example of an analysis that we provide, we actually provide many of them, this one is the easiest to explain, is policy equivalence. So suppose that you have a set of policy and you want to refactor it, and you want to make sure that you didn't introduce a bug when you refactor it. Okay, you didn't add more permissions, you didn't remove permissions, you just made it look nicer. Okay, so analysis can help you with that. And here's an example. So here are two policies. The first one says that all principals can perform the create list and get own list action on this tiny to-do application. And here interns can't create lists, okay? And we want to refactor this into just one policy. We want to get rid of that forbid because people are generally scared of writing forbid policies, which is always kind of interesting, but people don't like forbid, so we're going to get rid of that forbid. So here it is an attempt to do that. It seems like a pretty reasonable attempt, right? I'm just merging the semantics of these two and hoping that my set of permissions remains the same. Is it the same? I mean, this looks like a pretty reasonable attempt, right? But it turns out that I did this incorrectly. And the analysis is going to generate a test case. It's actually going to analyze every single possible input, every request, every state, potential state of my data store that's consistent with my schema. And if there is one on which these two things are different, it will synthesize it, it will find it. So here is an input on which the left-hand side says, yes, this is allowed, and this one says no. So why is this allowed? Well, Aaron is an intern and he's allowed to perform the get own list action, right? He is, according to the policies on the left. but he's not, according to the policy on the right, because I didn't rewrite that quite right. There are many ways to fix the thing on the right. Here's a super simple one. I make an exception here for the create list action, and all of a sudden, the analysis is just going to tell me, yes, they are equivalent on all possible inputs. The way that this works is by symbolically compiling policies to logical formulas and calling automated theorem provers, which are called satisfiability modular theory solvers, to prove that these two sets of policies are equivalent. And this analysis makes no mistakes. If it tells you that the property holds, it really does hold for all inputs. And if it tells you that it doesn't hold, it gives you a concrete counterexample, a test case that shows a violation. All right. So final bit, we're going to quickly talk about the performance and how we actually built Cedar. You can check it out. I highly encourage it. It's quite fun to see this kind of code on our GitHub website. The Cedar itself, the thing that you run in production, is built in Rust. For that reason, it's very, very fast. Typical request takes less than 10 microseconds, which is 28 to 80% faster than other authorization engines, which are based on data log in the case of Rego, and on relation-based access control in the case of OpenFGA. We show that Cedar components, like the authorizer and the type checker and the symbolic compiler, are correct by doing something called differential random testing. So what does that mean? It means that we build each component of Cedar, which is a lot of work, twice. Once in Rust, and once in this special, beautiful modern functional language called Lean, which comes with a built-in theorem prover. So the Lean is our specification, but it's actually executable. So every night we generate millions of tests. We feed them to both the specification and the implementation. We check that their outputs agree. If they do, you have one piece of evidence that you got your implementation right. If they don't, you found a bug in the implementation. Okay? So why is this useful? Well, it's useful because the Lean specification is much, much smaller than our Lean code. Everything I talked about today, you can actually, all of the components, even these really sophisticated algorithms that are reducing policies to logic, all of it altogether is only 5,000 lines of Lean code. You as a human being can sit down, read this, and convince yourself that these properties of Cedar that I told you about actually hold. And not only that, because Lean comes with a built-in interactive theorem prover, for all of these properties that I talked about, we have actually proven that they hold for the language design. So what does this bias? Well, it bias some really good bug finding ability. This is a lower bound on the number of bugs that we have found. We kind of stopped counting last year. I think we'll resume again. But DRT alone found 26 bugs as of sometime last year. And we have also found 6 really deep bugs that you can't find with testing because of we failed to be able to complete proofs. So we had to refine our design so that the proofs can go through and we can catch and fix these things before they ever reach production. And that brings us to the end of my talk. Thank you for your attention.
I had a question, a couple of questions actually. One is, you mentioned a common expression language, right? How is Cedar different from CER?
Different in a couple of ways. So we have the in operator differs. So CL doesn't have any notion of hierarchy. So that's special to Cedar. The type system is much stronger. So the cell type system is more forgiving. And cell has a couple of additional operators that we don't include in Cedar because they would not be analyzed. They would make the language non-analyzable. So it's very carefully chosen so that we can get all the properties that we want.
Got it. My second question was, you mentioned that it's able to actually generate test cases to figure out whether two policies are equivalent, right?
Mm-hmm.
How exhaustive is this test case checking? Like
complete.
Okay.
So the space of all possible inputs is infinite. It will check the entire infinite space because it's not, it's conceptually, it's checking all of the inputs one by one. In reality, it's not really doing that because it's not possible. It's using a theorem prover to prove that no bad input exists. And if that proof fails, the result is a test case that shows why the proof fails.
But to generate the test case, you might have to do some brute force, right? For the solver to converge.
The solver, yes. So the solver internally, we have designed Cedar carefully to give you the best possible case, which is the solver remains decidable. So what that means in practice is that the solver is guaranteed to come back given enough time.
Right.
Enough time may be, the age of the universe. But in practice, solvers have very good heuristics. So typical Cedar queries come back in milliseconds.
Nice.
Yeah.
So I was working with MILP solvers.
Yes.
And those take quite a lot of time.
Yeah. So it's a similar problem. They're also working on NP complete problems. Right. This is working on NP complete problems. These are pretty fast. They come back in milliseconds in our experience.
Any other questions?
Just a comment. I mean, in the DLT world, if you've ever tried to design any kind of breaching contract or really any kind of contract, authorization keeps you up at night. And what have I missed? What possible authorization attack or mistake or unauthorization have I put in here? Unintentional authorization. I think one of the most lucrative fields for contract work is I'll speak loud here. Is checking the authorization flow, especially between contracts, right? Over bridging. Just reinforcing that having some sort of framework to make sure that you have your authorizations in check is incredibly important in this field. Incredibly important when you're going across different identity spaces.
Oh, absolutely.
To translate what Steve's saying, you've just taken a whole bunch of business away from Accenture.
No. You can use our analysis to automate your business and make it faster and better.
Cedar's amazing. One question might be a giant softball, but given the rapid multiplication of AI agents, do you think Cedar is a good fit for agent-to-agent interaction authorization, especially because of its performance?
Yes.
Cool.
Absolutely.
Last question. Did you work with Phil Wendley at all on any of this?
I know Phil, but we haven't worked on this particular aspect of it. Yes.
I know he worked on the formal proof part about it. Yeah, he's retired, but
yes.
I just talked to him yesterday and told him about coming to a Cedar talk. He's writing a book on authorization. I don't know if you knew
that's
that.
fantastic.
Yeah.
He worked a lot in the zero trust space.
Yeah.
Where you basically have to have super fast and super reliable authorization because you're constantly authorizing every single request. It's not, there's no wall guard. Once you get in, you get access to everything. No, everything gets checked every single time.
And that's exactly what Cedar is so good at. So thank you I want to thank Amazon for their contributions to a giant open source jewel here.
Yeah, I think we've applied to be a part of CNCF as well.
Yeah.
So
yes. So fingers crossed. We're gonna get into CNCF soon.
Round of applause for me. Thanks, Emina. That was awesome. Learned a lot. We now have. Okay, hold on. Right. Drum roll for Drummond Reed. I've been waiting to say that. Sorry. So Drummond has spent a quarter century in internet identity, security, privacy, and trust infrastructure. He is the Director of Trust Services at Gen Digital. He is the co-author of the book Self-Sovereign Identity and the co-editor of W3C Decentralized Identifier Specification. At Trust Over IP Foundation, Drummond is the member of the steering committee and is also the co-founder of the First Person Project. Super cool to have you here, Drummond. A warm welcome to you.
Thank you. Good, and the slides are queued up here.
Yeah, you can just
Just click that guy there. Is that working?
yeah, you can just
Oh, there we go. Cool. Thanks very much. I know we just have like 15 minutes left, but I'll try and make this. It's not going to go as deep as Cedar. We're solving a different kind of problem with the first person project. And need to update. I actually left Jen in May. Jen did help. I want to give them a lot of credit for laying on the foundation for what we're doing here now with the first person project. But just as much, I want to credit 4 different projects at the Linux Foundation. Okay, we're here under LF Decentralized Trust. That's one of them. Trust RP moved under LF Decentralized Trust last October. We were an independent project, but when the Hyperledger umbrella got raised, we fit in underneath it. I think we're doing a JDF project. We're going on the standards. But we're also very close to Decentralized Identity Foundation. And then Open Wallet Foundation. So all 4 of us have been collaborating on what I'm going to be telling you about here today. Let's see if that works. Yeah, good. Okay, so I'm going to go fairly quickly, but this is a very advanced crowd. I know that. So that's not a problem. Anyway, we'll just cover these things. Why is it called the first person project? Yes, it's about proof of personhood, but actually the term comes from a blog post from Doc Searles, one of the co-founders of Internet Identity Workshop, which the next one is number 41. It happens twice a year. So we're going to our 21st year of doing this conference. Anyway, he wrote this blog post about 10 years ago on first person technologies that act in the individual's interest first and foremost, right? And this is a quote from that I really like, especially the lower part about it, because it underscores that we need to pay attention to these things because more and more of what we're doing in our technological infrastructure is being reflected in our societies around the world. Enough said about that. All right, so problem space, proof of personhood. Everyone familiar with that general problem set, proving a real person online? Not a dog, exactly, which is the Internet Workshop logo. It's actually 2-part problem when you dive into it. There is, are you a real person? And then, are you a unique person? Second part is, I mean, both are hard. Second part is a lot harder. This is interesting. I think that the switch to this background is totally wiping out the slide. Is there a different?
you can just pull up the slides that you sent.
Perfect. Yeah. Yeah, but if you're online, it'll be easy to just show the.
It's never a good event if there is no technical today.
Oh, yeah, exactly. Just to that.
Okay.
There we go.
So let's just try presenting
From that, yeah, that's perfect. Those will work. Yeah. Okay, good.
better.
All right. So we just looked at that, and now we'll go down to this. Okay, so first person project, again, 4 different collaborating organizations, but I'm going to give you the context around why we were after this. How many folks are familiar with formerly WorldCoin? You're not. Are you familiar at all with that? That's called the orb. It's now called World. Was called WorldCoin when they launched it 2.5 years ago initially. It's a project that's co-founded by Sam Altman from OpenAI to solve the problem of personhood with a biometric device, specially designed to do this, that basically takes an iris scan, basically hashes that to, for privacy purposes. And then there's a multi-party computation that then puts it into a Merkle tree on a blockchain. It's the world blockchain, and that is associated with the world coin. So it is a way, if it was able to enroll everyone in the world, to actually provide a universal solution for privacy-preserving proof of personhood. There are a lot of people that have a concern about a biometric global biometric database of any kind, but also one that is controlled by a company with for-profit investors. It's a challenge, I'll put it that way. It's certainly one approach you can take to this, but when they launched, there was a lot of sort of incoming questions and pressure on the decentralized identity community to say, you know, isn't there another alternative to this? This is going to be more privacy preserving. So, in fact, we had been thinking about this for quite a while. And this is fascinating. Vitalik Buterin, when the world went to him to basically look for an endorsement in 2023 to say, look, we've got a solution. Ethereum and the whole, you know, Web3 community really needs proof of personhood for DAOs, for many other situations where you want to make sure it's a real person. And they had him analyze it, and he summarized it. At the end of this long essay, he summarized his conclusions with this chart. And this third column is WorldCoin, specialized biometric solution. He actually comes out and says, I think it's the best approach is called a social graph-based approach. But the problems he saw with it, and I think realistically, from his point of view, privacy. If you put any sort of a social graph on a blockchain, you have real, you know, privacy questions about it. And then you also worried about accessibility and scalability because of, you know, blockchain's limitations. Well, he was looking at it through a blockchain lens. I don't blame him. He's Vitalik Buterin. But if you look at it through the lens of those of us working on decentralized identity and DIDs and VCs, we're like, wait a minute. We can build, with the right design, a decentralized trust graph. And if we take that approach, we can get all the securities after, all even better decentralization. We can make it highly accessible and scalable and very private. And with that, we said, wait a minute, this is a broader solution than just proof of personhood. Yes, it will solve that problem, but it will solve many other trust problems across the internet. And that's why, you know, all of the projects that I mentioned earlier, but in specific trust over IP, that's why we were started 5 years ago, is to actually figure out what we need in terms of protocol stack and governance for trust on the internet. So I'm going to quickly, you know, keep an eye on time here. So what is this decentralized trust graph? It's actually not very complicated. I mean, carrying this out at scale is going to, you know, we'll talk about what that involves, but the actual components, I'll put it this way, it's way easier to understand than Cedar. That's real rocket science. This I can explain here fairly quickly, okay? It requires two types of verifiable credentials, okay? Signed digital credentials. We don't need to get into the exact format of those credentials because, you know, there's format wars around all that. Let's just assume one of those formats is going to work just fine. But these two specific types of VCs, one is called a personal credential, and the other one is called a verifiable relationship credential. And I'll quickly explain what both of those are. So personal credentials were essentially the stake went in the ground a year ago with a paper that came out. You can scan that QR code to get it, or you can just type personal credentials into any browser, and it's the first thing that comes up. It's very widely referenced, 32 authors of that paper, and you can see all their affiliations. Interestingly, the top two authors are from OpenAI. So it caught a lot of people's attention. Wait a minute, OpenAI is promoting a non-biometric solution to proof of personhood. They are no longer at OpenAI. I don't think because of that, they took their own directions. But anyway, it's a 63-page paper. I highly recommend it if you are interested in this topic. It goes very deeply in, but it basically boils down two requirements for these credentials. The first one is the issuer, strictly through governance, assigns one per person, okay? And the second one is, because you're going to use this credential, the idea is to be able to use it any place to prove you're a person, to be able to create an account with privacy respecting sharing of information. It has to support ZKP. It's just not an option, which, by the way, European Digital Identity Wallet Initiative has also arrived to that conclusion. They haven't figured out what ZKP they're going to use, but they're down that same road. So those are the two requirements. And that means that the issuers of these credentials are the anchors essentially in this decentralized trust graph. And so you see the issuer up there. We have Bob and Alice. We'll talk more about it in a minute. Each getting a PhD in an ecosystem. Now, this is the important point. That credential only identifies them as a unique person in the context of that ecosystem. There will be many thousands of those, okay? every government, every company, every university, every non-NGO out there, they all have this policy already, right? They only want you to have one account, but then one citizen, right? So they're all in a position to issue those. We just need an overall architecture and initiative to have this happen, okay? Now that does mean you as an individual can have multiple of these credentials, of these personal credentials. Any one of them can prove it. The more you have, the stronger that proof could be, as long as it's privacy preserving. Make sense? Okay, we're halfway there. Now the second one is that's a pretty good graph, and it might solve that problem, but it doesn't get into the full strength of what we can do if we could also have a way of proving our person-to-person relationship, our peer relationships. That's where the name first person really fit. If I know Steve, I've actually known Steve, I had lunch with Steve, I can attest, I really know him.
Highest form of authentication.
Yeah, it frankly is. And we're going to get to the Linux Foundation really likes that too. So what we're in the process of designing when this all came up at Trusted IP was verifiable relationship credentials. And I have to plug Phil Windley's. As a co-founder of IW, we have several sessions at the last one on personal credentials. Our first person project. And afterwards, Phil does what he does very well. He's a great writer, and he wrote this blog post. So if you really want to dive into this, that's the QR code you can go read that. That really explains all this in more detail than I'm going to cover right here. But my favorite description of verifiable relationship credentials actually came from Jim Zemlin at the LF Member Summit last March, when in the keynote address he did on the first person project, he said, easiest way to understand this is the modern equivalent of a PGP key signing party, okay? And after he did that, we had a 2-hour workshop the next day that he was leading. And I was like, oh my God, I need to show him exactly how that's true, okay? So I went back to my room and created this Bob and Alice illustration of how that's true. So we're going to give Bob and Alice, and we're calling it the agent wallet, because you have agents that are acting on these wallets, and the industry is yet to determine. I think what's going to happen is agents going to win out because AI is finally moving us in that direction. So what I'm going to do here is the equivalent, the first person project equivalent of exactly what you do. Actually, I'm going to ask this question. How many of you have used a QR code to set up a contact on any network? LinkedIn, WhatsApp, Signal, WeChat, you name it. We're going to do this. All of those will establish a connection on that network. What we're going to do here is establish a wall-to-wall, agent-to-agent connection with no intermediary. Okay? Alice is going to display a QR code. Bob's going to scan it and say, yep, I want this relationship. Bob's wallet generates a key pair and the associated DID document. These are decentralized identifiers. And that's now, and based on the address in that QR code, going to send it to Alice. Alice is going to check the nonce in that and say, yep, that's my QR code. I'm going to do the same thing for Bob. What we've done there is a pairwise private DID exchange. And that has created what we call a personal private channel between the two of them that they can use for anything. At the Decentralized Identity Foundation, there's a protocol made up for DID-to-DID communications called DIDCOM. But at Trusted RP, we have an even more sophisticated protocol coming your way called the Trust Spanning Protocol. But both of them could be used for this personal private channel. So now what we're going to do is Bob's going to say, okay, we got that channel. I'm going to generate my verifiable relationship credential. And it's going to have that key pair. I'm in the pairwise DID state step, and Bob is going to sign it. I'll talk about personas in a minute. He is the issuer of that credential to Alice. Okay, peer-to-peer issuance. Alice is not a holder of that credential. Alice, if she's satisfied, is going to do the same thing for Bob. And we have just completed in not microseconds or milliseconds, but probably like 2 seconds, a virtual key signing party. Okay, they now both have not just keys, but proof of their relationship with each other. With the pairwise DIDs, the only challenge is they can't really prove to anyone else because they're the only two that know those DIDs. They have their private channel. That's what the personas is for. So last thing I'm going to explain is the personas. How do we actually finally instantiate true privacy-preserving personas on the internet at scale? And the answer is we do it with mortgages. All this is going to be handled automatically by your agent and your wallet. We've already seen interfaces that would do this. And each persona is another DID. They're all controlled. And the powerful thing, and I'm going to just quickly explain, in this diagram of the key management and the DID going on inside of what we call a sovereign wallet, this bottom layer is all of those pairwise private DIDs. Any relationship, person to person, but also person to website, person to agent, whatever it is. It's just default. You never have to think about it, and they're never shared. There's no correlation that happens here. In the upper box is how we actually do intentional correlation. If you want to have a public persona, you're an artist, you're a politician, you're something, you want to have it, known around the world, fantastic. You can do that with a public DID. But I want to point out, even that does not require legal identity. You can be Banksy. Everybody, you can prove that's a Banksy out there and not have to reveal your identity. Okay, I mean any legal identity. Community DIDs. I want to have a DID, for example, as an open source developer that I use in my open source development projects. Either one or all of them that I participate in the Linux Foundation. I can have a community DID, but I have a separate one for my political interactions or my sports interactions. There's even this category of private DIDs. A DID that you only share when you really need to prove it's you, but it's not for any other purpose. Think medical records. Think legal documents you need to sign. This is how we can actually manage this. And the interface, as I said, yes, ordinary people are not going to understand, how to do that. But the interface to let you do that persona management is not that complicated. Again, we already have companies starting to implement it. So that's the essence. The last thing I'm going to point out is, so how is it privacy preserving? ZKPs. And what that means is you end up with the proof you're unique and human, and then the more verifiable relationships you have within an ecosystem, the stronger the proof you can prove. The nice thing is that, and this is a shout out to Hart Montgomery, the CTO of LFDT, when we first, after Jim Zemlin basically said, we're going down this road, he took on basically assembling what I call the ZKP expert team. It's led by a professor at Berkeley, Dr. Sanjay Garg, and he's got several grad students working on it. They brought in a couple other cryptographers. So we are going to nail down the ZKP. We need to do this. And finally have something we can do that's privacy at scale. And I know we're over time. We're right at the end here. I'm going to try to say, I will quickly show you, if you wondered, what did Jim say about this? He introduced that there are these 4 projects, but the problem the Linux Foundation needs to solve with this, the reason he made it his keynote address at the Linux Foundation Member Summit in March, is this problem. I don't know if you're familiar with the XE attack. It's the scariest malware attack in open source ever, and luckily it was caught. I believe it might have. I don't know if it was an Amazon engineer or somebody was doing some testing with an early release version of Linux and spotted a bunch of some unusual activity and traced it down and found this. That's the link to the Wired article.
He was a Microsoft engineer because he was doing something with SSH and something, and he found like something
That's it.
slow in a VM or something like
It
that.
was a Microsoft engineer. Exactly. Thank God he did too, because this article shows you just how scary it would have been. It would have been essentially a root access backdoor every place that distribution was out there. So Jim made the point that this is an existential risk to the whole of the open source industry. So he gave this challenge starting at the original LFDT member summit last October to all of us saying, hey, the Linux Foundation needs a solution to this. And he'd been introduced a first person project. After that, we started telling Daniela and Hart about this, and they brought it up to Jim, and Jim said, hey, we need this kind of a solution. And he references the same paper. We gave him these slides. And then he said, why should it start here? Because open source software not only has this problem, but we need to show the world what a solution looks like. And what we didn't expect is that, and we're going to start with the Linux kernel project. And we were like, what? You want us to start with the most valuable open source project in the world? But his logic was, if it works for them, and they already use a web of trust, you can't contribute to the Linux kernel project unless your key, your GPG key is signed by, I think it's one other member if you want to contribute, it's 3 other members if you want to be a maintainer. So he said, yeah, let's start there. So that is what we're doing with Linux Foundation. We've got to, if anyone's interested in working on that Linux kernel part of the project, we can get you on that team. So that's it. Last thing I want to say is, because this builds on work we've been doing in Trust over IP on the underlying protocols, everything I just talked about is now going to be standardized in the new working group we're going to be announcing next month. Decentralized Trust Graph Working Group was approved by the Trust over IP Steering Committee, actually, I think in early June, but we said we're not going to start the working group of December. So we're going to launch it next month, and we hope you all will join and dive into it. And that's it.
Yay.
Any questions?
I had a question.
Go.
So right now, one of the things I'm working on is authorizing and managing consent for patients, right? Having spoken to a bunch of folks who tried doing this for various government organizations, one of the issues that they pointed out was that building of something known as a master patient index. So this is an index which, okay, let me back up a bit. When a patient goes to a hospital, it's not just that hospital they go to. People want second references and they want to try out other hospitals, or they need to go to other hospitals because they traveled, right, all over the state. Sure. So different states have different policies, different laws and regulations. So it's kind of like each hospital or each ER they go to has its own version of the patient's identity or who the patient is. But somehow all of that data and all of those reports that are generated needs to be tied to that same patient, right? Yes. So these organizations spend tons of investments trying to build out a master patient index, which consolidates that patient's identity across all the hospitals or healthcare organizations that they've visited. So based on your presentation, do you think that maybe community DIDs would actually be able to allow a patient to create a verifiable credential of sorts and share that with various hospitals, which can then create that sort of connection with the patient? Can you, I just want to hear your thoughts on this use case.
My thoughts are incredibly short and simple on that thing.
Yeah.
Yes, with 3 exclamation points. And I'm not the only one who feels that. There's actually, I think I'll just make sure it's here. I'll go back to this. So anyone watching this can, we have so far the first project that's on the working group. There is a mailing list, and we don't have anything more than that right now. We are working on, well, there'll be a white paper coming out in the early September that will go into deeper what our plans are, but there are about 175 folks on the mailing list, and folks started asking, okay, we want to create sublists to talk about specific topics. The number 1 request on the sublist was healthcare for that problem. There are several doctors, folks in this space, and we've actually recognized when we did the work on DIDs initially at the, all the way up to W3C, that we could solve that problem, but we needed the rest of this to really make it feasible. So the answer is absolutely. I'd love to talk. If there's folks that are interested in that space, I'd like to point them with the folks on that list that are already wanting to do it.
Yeah, I'd be super interested, because also now I think June or July 31st, 2025, some Kennedy, I don't know who, Robert maybe, he announced that, the world is moving towards a more interoperable healthcare system. So I think Amazon is also one of the participating companies to something known as a CMS pledge, where we try to sort of consolidate patient identity. It's an interesting piece of news if you want to check it out. I think it's pretty cool. It's a good use case.
It's, privacy at scale for very sensitive data like healthcare records, one of the hardest problems in the whole industry. And we knew when we were starting work on DIDs, which started in 2016, it took us 7 years to get that all the way to a W3C standard, which, by the way, when we got it there were 3 formal objections. You might know the story, but it was ironic. It was basically the 3 browser vendors. why would they be objecting to a new way to do trust on the internet, right? Luckily, we overcame those. It is a W3C standard, but we said we have to have that piece, but we need a bunch more pieces before we can actually solve that problem. Now, I think we're in a position to do that. So I would love that to see that as one of the
I'd love
one
to
of the
chat
things.
more about it.
Oh, absolutely.
Yeah.
Do
That's
you think it's a people problem or a tech problem?
no. It is very much both. In fact, I would say across all of this, I mean, with TrustRP, you may not be familiar with it, but we started it saying we need a new stack for trust, not a replacement stack, something higher, but this stack is tech and governance, and you can't separate. You have to have the governance. This largely in part, this decentralized trust graph solution will only work with personal credentials, which are trivial in technology. It's all about governance, right? We're going to have to trust the personal credential issuers. So yeah, I'm a huge fan. I co-chaired the governance stack working group for the first 2 years of TrustRP because that's what we were best known for. I'm going to tell you right now, you're going to start to hear soon about the technical stack because it's a 4-layer stack, just like the TCP/IP stack. But the most important part is the 4-layer stacks have a spanning protocol. With TCP/IP, it's the IP protocol. That's what made the internet possible. What we have finally designed and is now implemented, well, there are 2 implementations, but one at the Open Wallet Foundation in Rust is a trust spanning protocol. And so you can get cryptographic verifiability between any 2 decentralized identifiers anywhere. It's just like the internet, just like IP, but it's IP for trust. And that is not, you won't be surprised to find out, well, who's now very interested in that? Well, you've got MCP out there, and A2A, and a new project that's at LFDT called Agency, spelled, take out the vowels, that came in from Cisco. All of them are basically, oh, here's the semantics of what we need, but what do we do about trust, right? Well, we're already running an MCP over TSP. We're calling it TMCP. And then we're about to tackle TA2A. And so if you run those protocols over the trust layer, you get not all, but all the cryptographic trust you need, and you can just then layer in the human trust in things like verifiable credentials, especially privacy respecting ones. So
how complicated are these protocols and this crypto? So the reason why I'm asking is formal verification has been very successfully applied to very complicated protocols like Paxos, for example, and also to crypto implementations within AWS. Is this something that would be interesting in this domain? Like, are the protocols complicated enough that you would want to prove something about them? Is the crypto complicated enough that you would want to prove some properties of the implementation of the crypto and so on?
These are such softball questions. I love this today. Yes, and yes. Which is actually one of the reasons that I was talking with Phil, because he did work on the formal verification. We totally, the Berkeley team working on the ZKP, that's what they want. They want, I mean, if we're successful, it will become the largest implementation of or use of ZKP on the internet, right? It'll literally, every single site, every application that wants to ask you for just proof of personhood or proof of uniqueness will be able to ask for a ZKP credential, and they'll need to trust it. So they're preparing both the papers and the implementations. But yes, that needs to be formally verified. And then also the trust spanning protocol, where we've been talking about it. It's as simple, that's the whole point of the spanning protocol, as simple as you can make it, no simpler. But yes, we'd love to have that too. Are you interested in helping us with that?
Let's talk.
That's why we come to these events on Friday afternoons.
I have a few PhD students lying around.
I'll call that a success for our first meeting right there.
Oh yeah. No, we're super interested in that, and yeah, it's like just like Cedar is just this amazing tool that's out there. Which, by the way, the folks I know in the AI agent community, I was tackling these trust problems. I'm just like Cedar, and they're saying, yeah, we think that's right. So good job.
Thank you. Likewise.
Can I ask?
Go ahead.
This might be a new question because this is the first of these for me. But one of the key pieces seem to be the thing that issues the credential, right?
Yes.
At the end of the day, that's kind of your root. Who do you think will play that role, or who's in the past played that role? In the sense, it has to be someone who is trustable but still decentralized, which is like, I don't even trust the government nowadays, sort of.
That's one of I strongly encourage reading one of the reasons the personal credentials paper is 63 pages is that half of it is about that, discussing that problem. And I think the most powerful thing about it is it's not going to be one entity.
Okay.
Yes, you can use governments, but you can also use companies, and you can use universities. You can use open source projects. We think one of the places to start is not trying to go get governments to do this right away, although there are several that are already using SSI, like Bhutan and British Columbia and Canada, that are already interested in doing this. We think let's work bottom up. Let's get individual communities, and guess who's a great initial community, right? I was on a call yesterday about how is Linux Foundation going to be an issuer of a personal credential. It's not actually that hard when you get a smaller community. Go ahead, Steve.
I was just going to point out the fact that it can be peer-to-peer trust. It goes all the way to the smallest level. Those around you, your community. The oldest way we used to do trust. Who do you know? Oh, I know that person.
Exactly. And so the other thing that I think is quite powerful is we're already getting folks saying, wait a minute, we don't have a big community, but we have really strong, we can do the person-to-person thing. They can build up to the point where the community can then have a strong enough way of doing it peer-to-peer that the community can then say, okay, we can issue them the personal credentials. So we can work bottom up and top down with governments or companies. The Linux Foundation #1 choice besides themselves to issue credentials for developers is their employers. If employers will start just issuing an employee credential that is one per person, that'll work.
What about certificate providers?
That is a great question. If you know some, you need to go bang on their door and say, get on board with this. Believe it or not, we've had a hard time just getting them to recognize that DIDs, decentralized identifiers, are a business opportunity for them. Some of them are starting to get enlightened about that. And definitely, because they could really help with that. Yeah. All right, I know we got a little bit over time, but
It's a sparkling conversation. A big hand for Drummond Reed, everyone. Round of applause. Thank you.
thank you for staying this long on Friday afternoon.
Yeah, I'm just gonna wrap up really quick. For our presenters, thank you so much for coming. When I spoke initially to Sam and Heather from Indicio back in, I think, maintainer days, I was like, what's the next big thing for blockchain? And they all said, it's going to be DIDs. And here I am working in identity with a past in blockchain, with really intelligent, really smart people in the room having these amazing conversations. And that's the whole point of organizing meetups. So thanks to Jessica, thanks to David Boswell, who's on the call, and also to Daniela, who I spoke to a few hours ago, but she's not here. But I think LFDT is going to continue playing a critical part in bringing community together to have these kind of conversations and identify interesting areas for research, for business. And as always, I'm happy to keep hosting and learning from everyone. So, and also shout out to Avi, who's my manager, who showed up here in support today. Okay, thanks everyone. And we end the live stream. David, thank you. Signing off.
Thank
Also, shout out to Deepika for putting together this amazing group of speakers across identity and blockchain.
That's a nice plug. That's my partner. And he has to do this, else I will nag him at home. Okay. And just one last thing. I think I can't change slides now, but we do have a survey. So before you leave, please sign up for that survey and just leave your thoughts on it so we know how to keep organizing better events. And we take notes. We take good notes and we're good at feedback. So thank you.
Thank you, everybody.